So hello guys. The last part we end up here on the we end up here on the structural analysis. Okay, so I'm going to follow all the steps shown in this book once again. Let me switch to robot. Okay, now I'm going to perform the calculation of the structure, and I'm going to change the layout to results. Okay, I'm going to maximize this box. I'm going to pick load number 4 and check the deformation. You may see the load number 4 is this distributed load. Okay, apply, and you may check here the deformation. It seems right to me. Okay, I'm going to turn this off, apply. I'm going to switch to the reactions table, and now I'm going to select the FZ column. I'm going to format, alignment, and center it, and also make it bold, as you may see. Okay, also I'm going to right click and go to table columns, and in the supports I'm going to pick the support code. The support code looks like this: X, 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 X. Each node has 6 degrees of freedom, and if you have an X, it means it is fixed. Otherwise it will be an F, which means it is free. Okay, these are all the supports, and as they are as the supports are actually fixed, as you may see, all the degree of freedoms are of course fixed. Okay, that is why I've got that code. I could also check that over here. Right mouse click, display, go to the support codes, and apply. You may see that over here. Okay, well, let me switch once again to results. Nothing else to see here. Let me turn off the display of the support nodes. Okay, bye. And now I'm going to the steel design. I'm going to pick columns 1 to 10 just to show you elements 1 to 10 just to show you which element are these, as you may see. And I'm going to copy this and paste it right here. Okay, I want all the loads for the calculation of the steel members. Okay, all the load cases, and I'm going to run the calculations. I'm going to switch this over here. I'm going to check the results for column number 4, and you may see here the simplified results. Okay, very well. Now we are going to turn our attention to the design of steel connections. Okay, cancel out of this, and I'm going to the layout column and switch to connections. And here we are. As you may see, I've got no connection whatsoever defined. I've got here one tab saying scheme, connection view, structure, and results. Only structure has something. So now I'm going to do as they say in the exercise, and I'm going to view, projection, ZX. And I'm going to select, while pressing the control button, I'm going to select both the left column and the left side beam. This and this. which means that I want to define this connection over here, okay, between this column and this beam. Okay, now I'm going to connections and define a new connection for selected bars. I could also define a connection and select one of these connections, the supported connections for robot structural analysis professional. Okay, but if I define and calculate the connection this way, it won't be linked to the structure. I want a connection that is linked to the structure, that has the loads and the stresses and the forces from the steel structure that I have here. So I'll have to pick this new connection from selected bars. Okay, sorry, connections, new connections for supported bar. Robot is going to choose the best connection for this, which is a beam to column, okay, frame knee connections, and I want a welded connection, okay. That is a connection type that I want. I don't want a bolted connection, I want a welded connection. I could define the brackners, the stiffeners, the welds, the code parameters, but I'm going to stick with what robot is giving me, okay. So I'm going to apply and okay. And you may see that robot give me this sign over here, which is linked to this, the first connection. So now I'm going to run the calculations. I'm going to connections and calculations. The node list is node, okay, number 2. Connection list is connection number 1. I could pick the load cases for the definition of the connection. I'm going to choose them all, and I'm going to run the calculations. The first thing that when I run the calculation, you can see the ratio over here, okay, which means that our connection is okay. And now I can check the scheme, which is a drawing of the connection, as you may see, AGV 300, AGV 340. And I have here a 3D view of the connection. Pretty cool 3D view. In blue, you've got the elements, and in green, you've got some plates to help the connection resist. Here in the results, you may see all the calculations that the robot made. You can see the geometry of the column and of the beam, the column stiffener, the material factors used, and the loads picked. These loads over here are picked from the structural model, okay, regarding all the combinations. I could do this by hand. What I mean by that is I could go to connections, new connection, and define a beam to beam connection. I could define this way, okay, but this is not connected to any structural element that I have in my structure. I could define this, apply, and now I need to calculate this. So I'll go to manual calculations and select the stresses that I have. I'm going to just run the calculation this way, and there you have. But remember, this is not connected to anything. This is just a way to calculate any connection available here in robot, just a way that you have to do that. Okay, so I guess I have to thank you for bearing here with me, and see you in the exercise number 7. Thank you very much.